All right, the first graph I've got is from section 4.1. This is a quadratic that is in standard form. So to do quadratics in standard form, we should have notes on this, but it's just an extra example. We want to find the vertex, and to do that we have to use this formula, negative b over 2a. Now your b in this case is negative 2, and we want the opposite of b, so it's going to be a positive 2 over 2a. Your a in this case is the number in front of the x squared, which is a 1. So when you simplify this, 2 divided by 2 times 1 will reduce to 1. So you know your vertex is 1 something. The rest of it is typing this into the calculator and going to your table of values by hitting second graph and finding 1 in the x column, which is right here. And you want to scroll to where that 1 is right in the middle. You want 3 numbers above it, 3 numbers below it. And you can see that 1 is negative 2. So that is your vertex. And what you're going to do is you're going to plot 1, negative 2, which is right here. And you're going to plot however many numbers you can that surround it. So I want to plot the 3 points above it, 3 points below it. So 0, negative 1 is here. Negative 1, 2. Negative 2, 7. And that's going to be the same thing on the other side. It should be symmetric. And then you've got your U shape once you connect your dots. Now you also have an axis of symmetry. If it asks for that, you can say it's what splits the graph directly in half, which is at x equals 1, which is the same number as the x value of your vertex. And then your domain and range are also important. Your domain for all quadratics is always all real. There is no restriction as to what x can be. It goes to the left forever, it goes to the right forever. So that's always all real. Your range, though, is based upon the y value of your vertex, which is negative 2. And since that is the lowest point that this graph ever goes, it is all y values greater than or equal to that negative 2. All right, the next graph is from section 4.2. This one is in vertex form. You can tell because it's got the parentheses and the squared. And to do this one, your vertex is the easy part. That's why it's in vertex form. It's the opposite of the number in parentheses, and then whatever number is on the outside, which is a negative 3. So your vertex is negative 2, negative 3, which is right here. And from there, you can also go ahead and say your axis of symmetry, which is at that same x value. So you know your graph is going to be cut directly in half at that same x value of negative 2. I've already got this typed into my y equals, so go to your table of values and find your vertex, which is negative 2, negative 3, which is right there for me. And I'm going to scroll until that number, just like in the last problem, is right in the middle. And I'm going to plot as many points as I can. So I'm going to plot negative 3, negative 2, negative 4, 1, and then negative 5, 6, which is right here. And then it's going to be the same thing. It should be symmetric on the other side. There's your U shape. Make sure you connect it with a smooth curve. And your domain and range, just like the last problem, your domain for any quadratic is always all real. And your range, just like the last problem, depends upon the y value of your vertex. And because this is a U shape again, and this negative 3 is the lowest that my graph will ever get, that means that it can be y equals negative 3 or anything bigger than that. So y greater than or equal to negative 3. All right, the next graph I'm going to do is in intercept form. It is also in section 4.2. This is the last type of quadratic. This one is in intercept form because it's got 2 sets of parentheses, and you're going to plot the x-intercepts first. And the x-intercepts are the opposite of the numbers in parentheses. So the opposite of negative 3 is a positive 3. The opposite of negative 7 is a positive 7. So I know that my graph is going to go through those 2 points, and because quadratics are always symmetric, I know that my vertex is going to fall halfway between those 2 points. So my axis of symmetry is going to be smack dab in the middle of 3 and 8. And if you look at it visually, you should be able to tell that that is at 5, which is right here. If you don't see that visually, you can just take the average of those 2 numbers. Take 3 plus 7, divide it by 2, and you do get 5. So I know that my vertex is 5 something. I also know my axis of symmetry is also at x equals 5. The rest of it is in the calculator just like it was before. Go to your table of values to figure out what 5 is. So if I scroll to 5, I can see that it is, whoops, I passed it there. I can see that 5 is right in the middle there at 4. So that's my vertex, 5, 4. And I can also see the surrounding points. There's 3, 0 that I've already got plotted. There's 7, 0 that I already got plotted. If you want to plot these two, you can, but you don't have to. But you can tell this is an N shape. The reason why it's an N and not a U is the fact that it's got this negative sign out in front. Now the rest of it, domain and range, is just like the last two problems. Your domain is all real for any quadratic. And your range this time still depends upon the y value of 4. But because this is an N shape, 4 is the highest point it will reach. It's 4 and then everything below 4. So it's y less than or equal to 4 instead of greater than. All right, the next graph is from section 6.5. This is the square root graph. This one does not have a vertex, but it does have a starting point that may help you with graphing this. And your starting point is kind of like your vertex in your quadratic. It's the opposite of the inside, which will make that a -3, and then whatever number is on the outside, which is 4. So that is your starting point, and that's really not a vertex. You don't have to label that on the test or anything, but when you go to your table of values, you'll see that that will help you plot some points, because -3, 4 is the first point before all of the error signs that pop up. And the reason why there are errors is because you can't have negatives underneath the square root. So if you have like -4 for x, -4 plus 3 is negative, you can't take the square root of a negative. So we start at -3, 4, which is right here. And then we just plot as many points as we can. I can plot -2, 2. I can plot, if I scroll down, I can plot 1, 0. If I scroll down some more, I can plot 6, -2. And that may be the last one. Yeah, that's the last one I can plot that will fill in my graph. So if you look at your graph, it starts at your starting point and goes down on a curve through those remaining points. It doesn't go past this point, so don't extend your graph. So all I need from you on this graph are the domain and range. Okay, there's no asymptotes, there's no vertex, so domain and range is all you need. But your domain and range depends upon your starting point, which is why I like to write it down. And your domain deals with x values, and the x value of your starting point is -3. So all I got to do is figure out, is it greater than or less than? Well, this graph starts at -3 and goes to the right forever. So that's all values greater than or equal to -3. Your range depends upon your y's, and your y starting point is at 4. And since this graph's highest point is 4, it starts here and then goes down forever. Because it goes down, it's less than or equal to 4. Had this graph gone up, it would have been greater than. Alright, this is also section 6.5. This is this cube root. To type this in the calculator to get the cube root, you go to math, and you scroll down to the 4th one, and then type in the rest of it, making sure you type it in correctly. Now, cube roots are probably the easiest ones you'll do. There's not really a starting point, but there is like a central point that may help you. And the central point is the opposite of the inside and whatever's on the outside, which is 1, 1. And the reason why that's helpful is because when you go to your table of values, you have a starting thing to look for. Like there's 1, 1, and you can plot the 2 points around it. So here's 1, 1. I can plot 0, -2. And I can plot 2, 4. If you plot just those 3 points, it looks like a straight line, so we need more. So I'm going to scroll up until I get another point, which is -7, -5. And I'm going to scroll down to get the other side, which would be 9, 7, which is right here. And the way this graph looks, it looks like an S, kind of a squished S. And you can see it kind of increases slow and then really fast and then back to slow again. So make your graph nice and smooth, continuous, no sharp edges. And it looks like this. What's easy about these graphs is they're always all real. Every single time.